All right, so the next thing on 2.6 that we're going to talk about is the properties of logs. So properties of logs is just like the properties of exponents. So what I'm going to do is I'm going to write both of them so you can see how they work hand in hand. So the first one is as an exponent. Okay, so the first one is when you have x raised to the 0 power, or anything raised to the 0 power is just 1. As a log, it says log of whatever my base is of 1 equals 0. So again, all I'm doing is I'm rearranging it. Here's my base, here's my total, here's my exponent. Here's my base, here's my total, here's my exponent. Okay, so anytime we're going back and forth between exponents and logs, it's just a rearrangement of the positions. The next one is if you had, let's say you had 3 raised to the first power gives you 3. Makes sense, right? 3 raised to the first power is just 3. Well, as a log, it could look like this. Log base b, whatever your base is, of b is going to always equal 1. Okay? So what this means is if I were to write this in general format, b raised to the first power gives me b. Log base b of the total b gives me 1. So here's the trick. Anytime these two values are the same, your exponent's 1. Your answer will always be 1 because this is saying b raised to the first power gives you b. It's just a property. So the shortcut is these two things are going to be equal to each other, whatever the base is. So if I go back to this 3 raised to the third power, written as a log is log base 3 of 3 gives me 1. So you can see the base and the total is the same thing, which means my exponent is 1. Okay? The next one, the next property is, I'll write it over here first, is log base b of b to the whatever power is going to equal that exponent. So this is kind of a little play on words, if you will. This is saying what's the exponent on b that gives me b to the x power? What's the exponent on b that gives me b to the x power? Well, it's x. The exponent is x. So as an exponential function, it would look like this. B raised to the x power gives me b raised to the x power. So the exponent on b that gives me the total b to the x is x. Here's the trick. Look, since this b and this b is the same, if I cancel those, I get the value x. All right, so let me do this in terms of a number. So log base 5 of 5 squared gives me 2. Okay, so 5 raised to the second power gives me 5 squared. It's kind of a little play on words, if you will. 5 raised to the second power gives me 5 raised to the second power. Okay? All right, so those are the first 3. So let me continue. So these are all the different properties. The fourth one is another play on words. Let me give you the log first. Let's see, log, or b. So this is the exponent. B raised to log base b of x equals x again. And x cannot be 0. Oh no, I'm sorry, x has to be greater than 0. Sorry about that. Okay, so since this is an exponential form, okay, b raised to an exponent that gives you x equals x. That's what this is saying. b raised to an exponent that gives you x is gonna give you x, right? Because this is a total, and this is the total here. Okay, so here's what this means. If I had 3 raised to the log base 3 of 9, 3 raised to, and remember a log is an exponent, so this is actually saying what's the exponent on 3 that gives me 9. Okay, the exponent on 3 that gives me 9 is 2. What's 3 raised to the 2, or to the second power, is 9. So the shortcut to this is, look, these two things cancel out, and 9 is my answer. Okay, so as a log base b, okay, of my total gives me the exponent. So look, all I did is I rearranged. This is log base b of this total gives me this exponent. Well, it's the same thing, right? It's exactly the same thing. Okay, so there's that one. And then the next one. Okay, so these are properties. These are log properties. So let me write it out first. And then I'm going to do the same thing over here with an exponent. So what this is showing is if I have two values that I'm multiplying together, when I expand it out, or when I work it out, I'm actually adding. Where this comes from is, let's say I had x raised to the 7th power times x raised to the 5th power. So remember, going back to exponent rules, when you multiply with exponents, you add the exponents, right? So when I multiply with exponents, my base stays the same, but I add my exponent, so 7 plus 5. So it's going to be x to the 12th power. A log, remember, is just another way to say an exponent. So it literally is the same thing. When I multiply with exponents, I add the exponents. When I multiply, I add. So let me show you an example of this. So log of 3 times x. What I'm going to do is I'm going to split this up and add. I'm taking the two terms that I'm multiplying, and I'm actually adding them, because this is an exponent. So when I multiply with exponents, I add the exponents. And again, these are exponents. Okay? Those are exponents. So that is the product rule. Okay? You learned this as the product rule. The next one is the quotient rule. Okay, so the quotient rule says if I have two exponents and I'm dividing them, you subtract the exponent. So again, there's another video earlier in the semester that you can go back to if you want to go over these rules. So this is the quotient rule that says if I divide, I'm going to subtract my exponents. Okay, so same thing with a log. If I have log and I'm dividing two things, I'm actually going to subtract the two things. Okay, so this is called expanding out. I'm taking one single log and I'm expanding it out so that I can more easily solve. So an example of this would be log of, say, 15 divided by x is the same as log of 15 minus log of x. So quotient rule, when I divide, I subtract. Product rule, when I multiply, I add the exponents. And then the next one is the power rule. So the power rule, as an exponent, says if I have an exponent and then I raise that exponent to another power, I'm going to multiply these two exponents. So 3 times 4, which is x to the 12th. Okay, so when I multiply two exponents, I add. When I divide two exponents, I subtract. When I have an exponent on an exponent, I multiply those two exponents. Okay, so it's the same thing over here. When I have a log is just an exponent. So if I have log of x raised to the third power, okay, I'm going to multiply the two. So what I tell my students is I take this exponent and I drop it to the front and multiply. So all I did is I took this exponent and I dropped it to the front of the log and then multiplied, which is exactly what I did here. I multiplied the two exponents. This is an exponent on an exponent. So you multiply the exponents. Okay. All right, so let me give you an example of this. So if you had, let's say you had log of 3 plus x raised to the fourth power. What you would do is you would take this exponent to the front and then multiply. Okay, so drop it to the front and multiply. So those are the properties of logs. Next video, what we're going to do is we're going to start implementing these properties into the functions and be able to solve for x.